Alright, let's design a circuit right off the bat. Now here's the data from a Radio Shack 5mm red LED. And we can see here it says, right here, it says 2.6 volt DC. Now that's not the supply voltage. That's going to be the voltage across the LED when it's conducting. And here is the 28 milliamps, and that is the maximum amount of current that can flow through this LED without destroying it. Now let's take a look at your basic LED circuit. We're going to have like a 12 volt DC battery, or this could be the DC line in the computer, or off a AC power adapter. Now this is the basic circuit. You have a current limiting resistor, and this is going to limit the current so that this 28 milliamps is not exceeded. And then here's the LED. This is the basic circuit for an LED. Okay, now the first thing you have to know is what is the positive and negative lead of the LED. Now if you look at the LED, you're going to see from the bottom it's going to be round, and then there's going to be a flat region. That's typically the negative side. Also, if you look at it from the side view, it kind of looks like this. And what you have in here, you have a kind of a big piece of metal that goes down here. Now on top of this is going to be the actual LED. And then you have kind of like a skinny piece. And there'll be a little wire that goes from the LED to the skinny piece. And that goes down here. Now the long lead and the skinny thing here, that's going to be your positive. And the big fat one with the LED on it, and it's shorter, that's going to be your negative. Now this isn't always the case, but generally it is. Okay, now the one thing you want to do, the first thing you want to look at is this 28 milliamps. Now that would really glow pretty brightly. But I'll tell you, whether you put 10 milliamps or 15 milliamps, the eye is very difficult to see any difference. Maybe you'll see a little difference in brightness. So I wouldn't go for 28 milliamps. I would go for 10 milliamps. It's going to be bright enough, and you really can't tell the difference. So we're going to go for 10 milliamps of current. Now, and the voltage is going to be the 12 volt DC. Now this 2.6 volts, when this LED is conducting, it's like a short circuit. But it's a special type of short circuit. In order to get it to conduct, you have to have at least 2.6 volts. And so this thing, it stays at 2.6 volts. That's the voltage drop across the LED. And that's the specification here. Now, we have to figure out the current and the value of this resistor. Now we can see that the Ohm's law says that voltage, here we go, voltage equals current times resistance. And this is the resistor that we're going to try to figure out. So resistance equals voltage divided by current. The voltage we know, we're starting out with 12 volt DC. But look here, the voltage across this resistor is 12 volt on this side and 2.6 volt on this side. So we have to subtract the 2.6 volt to get the actual voltage across this resistor. And then we're going to divide that by the current. And because this is a series circuit, the same current is going to flow through the resistor as flows through the light emitting diode. And here it's 10 milliamps. 10 milliamps, we want to write it in amps. And so that would be 0.010 amps. Okay, so if we do the math, we come out to 9.4 volts divided by 0.01. And that equals about 940 ohms. Now, 940 ohms, you're not going to find a 940 ohm resistor, so we're just going to go with a 1K, 1 kilo ohm, which equals 1,000 ohms. And you don't have to be totally exact. You can do some engineering fudging on this. It's not terribly exact, but you have to be within the ballpark. Okay, so we'll have this, this equals to 1K. Now, when we hook this up to a 12-volt supply, we're going to limit the current to 10 milliamps. The LED is going to glow, and that's your basic LED circuit. Now, you want to what's called bias the LED correctly, and that means that you have to put the positive lead on the same side as the positive voltage. Positive goes to positive, and negative goes to negative, or in this case it goes to ground. If you were to hook it up the other way, then it would be reverse biased. And in that condition, it would appear as an open circuit. Unless, of course, you really applied a very large voltage, a reverse voltage in this case. And when that would happen, you would reach what's called the reverse breakdown voltage. And you would apply so much voltage that the LED itself would break down. In the process, it would be destroyed. And so you don't want to reverse bias. But let's say you're hooking up an LED and you don't know which way to go. On the motherboard especially, the current limiters are all there for you. If you hook it up backwards, nothing's going to happen. The LED just won't come on. You're not going to destroy it. Now, you don't want to leave it like that. But for the few seconds or 20 seconds that you have it hooked up, it's not going to hurt the LED. What you want to do is just turn it around because you want the positive to go to the positive lead on the motherboard. Over here is a 1K resistor. 1K is 1,000 ohms. This is a red LED, although it's not showing up as red. It looks kind of white. But here's the schematic for it. Here's the 1K resistor in series with the LED diode.